Hello, I'm Rob Reiner, Tachyum's Director of Product Marketing, and I'm here to present Tachyum's latest milestone, the development of our QA process for our Prodigy Universal Processor. Tachyum's QA processes cover both hardware and software testing of our Prodigy hardware emulation system, and this ensures that our first Prodigy Universal Processor is the highest possible quality for customers. Our QA testing covers component integration and regression testing, and the test workflow is fully automated. The testing workflow includes the following four environments. The build environment covers all the procedures required for building the hardware and software projects and to generate binary files for the load environment. The load environment deploys these files into the Prodigy hardware emulator. The testing environment runs the test jobs. The CI/CD, or continuous integration and continuous delivery environment, covers all the tools needed to fully automate this testing workflow. The build environment has two separate build flows. The software build flow covers the compilation of the Tachyum architecture test code or application. The created binary file is executable on the Prodigy hardware emulation system and ultimately on the Prodigy processor. The hardware build flow covers a synthesis of system Verilog code which describes the Prodigy CPU architecture. The binary file is loaded into FPGAs which run the Prodigy design. The load environment encompasses the upload of the generated binary files into the hardware emulator. First, the Prodigy CPU design is loaded by the Quartus programmer and the USB Blaster debug probe. This programming path is fully defined by the FPGA chip used. In our case, we're using the Intel Stratix 10GX FPGA devices. In the second step, the test application is loaded by the OpenOCD programmer and Seger JLink debug probe. This programming path is defined by Tachyum. The testing environment is the most complex part of our testing workflow. This refers to our hardware in-loop testing, where test jobs are interacting with our hardware emulator across different physical interfaces like JTAG, UART, GPIO, etc. This is more complicated than pure software testing, both in terms of the interaction with the hardware and the automation. The LabGrid testing framework, written in the Python language, helps significantly. For every physical interface, we have a software wrapper with a user-friendly API. The CI/CD environment automates all the steps described in previous slides. The entire process of testing automation is illustrated in this diagram. The automation flow can be logically split into four steps, which are coordinated by the Jenkins automation server. Step 1 is triggering the testing, where any changes in the source code kick off the build process. Once the build process is finished, build artifacts are provided to LabGrid, the hardware emulator manager. In step 3, the build artifacts are installed on the Prodigy hardware emulator and tests are performed. In step 4, the test results are collected, stored, and displayed in the dashboard. All reports from the tests are available via the Jenkins dashboard. For a brief overview of this dashboard, we have selected just the most important windows. The main window shows a list of the test projects with the last execution status. Here you can see that we are running low-level bare metal testing, and more complex regression testing is running inside the Linux kernel user space. By clicking on any test from this menu, you will get a window with more details about it. This window displays the build history and the trend of the test results. The test result window will be opened after clicking to the specific test from the build history. In the test result window, you can see all of the information about executed tests, as well as details about failed tests. The last window shows the results and logs of all the test cases executed within the test. All of the testing workflows shown on the Prodigy hardware emulator are fully reusable for testing the final Prodigy processor. Thank you for your time to watch our video demonstrating our QA testing for Prodigy. Please visit our website at tachyum.com.